we'll want to click the calculus, go down to find the derivative by the definition, and I believe that's the problem we're looking at right there. So let's write that down. Write it down. H of x is equal to 22x squared, and we want to find h prime of x. We're going to move over to the whiteboard and let's write the definition out in green like I've done on these others. So we have f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x, and that's all over delta x. We have h of x is equal to 22x squared, and we want to find h prime of x. H prime of x, that's what we want to find. So the first thing we're going to do is find h of x plus delta x. And that means we're going to take x plus delta x and plug it in right here. So we have 22 times x plus delta x quantity squared. Right, so we'll want to go ahead and multiply this thing completely out. And you know, I'm going to do a little side work up here, x plus, because we don't have enough room down below. But let's just do some side work. How's that? So that would be this part here. Right, so we have x times x is x squared, x times delta x, and delta x times x, and of course delta x times delta x is delta x squared. And then we can simplify all that down to x squared plus 2x delta x plus delta x squared. So you may have already know how to do all that, but you'd be surprised how many people forget. Now we have the 22 out here, so we'll want to multiply the 22 across. Now we'll just go ahead and finish that right here. So we have 22 times x squared, and then of course 22 times 2x delta x, that becomes 44 x delta x, and then 22. You know what? No, okay, we're good. I was thinking of the last problem for some reason. And then of course we have 22 times delta x squared. So there you go. Now we're going to write h, and I just about wrote f, h prime of x is equal to the limit as delta x approaches 0. Alright, and so we go ahead and rewrite all this. So this is 22x squared plus 44x delta x plus 22 delta x squared minus, right, minus the function, which is h of x, so minus 22x squared, and that's all over delta x. It's all over delta x. Well, as you can see, the function will always cancel out, so 22x squared, right, those guys are gone, and now we'll just rewrite. So we have h prime of x equals the limit as delta x approaches 0, so we end up with 44x delta x plus 22 delta x squared, and that's all over delta x. Now as you can see, we have a delta x in this term and 2 in this term, of course 1 at the bottom. We broke this up into two separate fractions. You would see that this delta x and one of these delta x's are going to cancel out. Of course that'll cancel out also there. And I guess I'm just going to write it like this. Trying not to scroll on the screen so you can keep your eye on everything. We end up with 44x plus 22 delta x, right, after we cancel out the delta x's. And now we can go ahead and do the direct substitution, plugging 0 in for delta x, so this is going to become 0, and we're just left with 44x. That's it. So we finally found it. Of course, you know what? We're going to be doing a lot of this in the rest of calculus, and we're not going to be doing it like this. We got shortcut methods. So h prime of x is equal to 44x. Now take a look at this. We have a 22 out front. We have a 2 right here. I wonder where that 44 comes from. Alright. Move back over to the web page. Let's hit answer. And of course you can see h prime of x is equal to 44x. And if we click the help button, which I will do, we kind of go through the same procedures. Right, I think I skipped a few things here, but anyway, you see how we did it in the video, right? Or in this video. Okay, so I will see you there. Bye.